Good morning, ladies. Welcome to Precalculus. I'm Miss Busselmeyer, and I apologize that I'm not there with you on your first day back this semester. I hope you guys had a wonderful break and that you had an excellent time on your service projects. I will be back in class on Thursday, and at that point we'll go over the syllabus and the outline of the course. But for today, I wanted to get started with the lessons because we do meet so few times this semester. You should right now have a notes packet that looks similar to what you're seeing on the screen. I will go through this notes packet just like I would during class. I will give you the vocabulary, I will give you the examples, and I will have you do a few problems independently. When I have you do that, I will just say, go ahead and pause now and try the next problem. We are starting in chapter 9, which is sequences and probability. There's a little bit out of 9.1, but the bulk of what we're doing today is out of section 9.2. So let's go ahead and get started with vocabulary. The first term is just the term sequence, and a sequence is literally just an ordered group of numbers. There are two types of sequences. There are many types of sequences. In general, there are infinite sequences and finite sequences. As I hope that you would guess, an infinite sequence is a sequence with an infinite number of terms. And a finite sequence is a sequence with a set number of terms. A term is simply a value in the sequence. A recursive sequence is a sequence where you have to know a previous value in order to figure out the next value. So we can say that it's defined using previous terms. And that's really the first kind of sequence that you start with. Then we look at the way that the terms are defined, and the first one that we're looking at is an arithmetic sequence. You would recognize an arithmetic sequence because it looks like a linear equation. Oops, let me erase that. Sorry, sometimes we do make some silly mistakes. So it's a sequence with a linear pattern. And with that pattern is the common difference. The common difference could be the slope of the pattern or the way the pattern changes. meaning that you will add or subtract the same value. All right, I will take a minute to zoom out so that you can see all of the vocabulary terms. Go ahead and pause this if you need to get anything written down. Sequences are written as functions, but they are not written in function notation. They're written with subscripts, and by subscripts, I mean things like this little n right here, right? So we read that a sub n equals 3n minus 2. So if I'm going to write the first 4 terms of this sequence, right, the first thing I would do is say, okay, well, what is a sub 1? Oops, and I did not want that to be yellow. So let me erase that really quick and let me go to a better color. Okay, so a sub 1 is equal to 3 times 1 minus 2. Notice that I put the number in the subscript right here in the function. Okay, and then once we're at this point, we can simply solve it. So the first term in our sequence is 3 times 1 minus 2. And 3 times 1 is 3. 3 minus 2 is 1. So my first term is 1. Let's look at the second term. A sub 2 equals 3 times 2 minus 2. Okay, so again, the number that was the subscript got put in place of n. And so, oops, and those are my dogs barking. So 3 times 2 is 6, and 6 minus 2 is 4. So the next number is 4. So a sub 3 is equal to 3 times 3 minus 2. So that's 9 minus 2 is 7. You put in the fourth term. Pause it here. So hopefully you plugged 4 in for n, and you got 12 minus 2 was 10. Another thing that I would like you to notice is the fact that there are commas in between each term, and then there's the ellipsis or the dot, dot, dot after the last term. The reason we do this is that we need to notate that this sequence is infinite, meaning it does go on infinitely. Let's take a look at the next one, because the next one is actually not an arithmetic sequence. This next one is a geometric sequence, and the reason that we can tell that is because here's my n, and there's n as the exponent. So if we've got n in the exponent, we need to think of this as being multiplicative. So again, we're just going to write up the first 4 terms, okay? So a sub 1 is equal to 3 plus negative 1 to the power of 1. Cool, so negative 1 to the 1 is negative 1. 3 minus 1 is 2, so my first term is 2. A sub 2 equals 3 plus negative 1 to the power of 2. All right, so we're going to plug this in our calculators, and we may or may not get the right answer. Remember, if you raise negative numbers to a power, you have to put that negative number in parentheses. Negative 1 squared is positive 1. 3 plus 1 is 4. So the next number is 4. How about a sub 3? I get 3 plus negative 1 cubed. Well, what's negative 1 cubed? It's negative 1. 3 plus negative 1 is 2. If you had to take a guess, what would you guess the next number would be? Go ahead and guess that now. Pause it here. So if you figured out that it's 4, you are correct. Why does this happen? Well, we're raising a negative 1 to a power. Negative 1 to odd powers is negative, and negative 1 to even powers is positive. So at this point, all we're doing is either adding or subtracting 1 from 3. So this, again, is a sequence, and it can continue infinitely. So now I'm going to have you pause the video and do the next example. Hopefully you got 3, 5, 7, and 9 as the first 4 terms of the sequence. And again, just reminding you that the number that is the subscript replaces n in every single one of these. From here, you could probably even predict the 100th term of this sequence just because of the way that it's set up. All right, so we should now be at the end of the page, and take a look at the next set of sequences. So here is example 2. Oh, see, I did it again when I wrote when I didn't mean to. So writing in the first 4 terms of this sequence. Again, I will walk you through this process, and then I'll have you do the next one on your own. So write the first 4 terms of the sequence. So a sub 1 is going to equal -1 to the power of 1 over 2 times -1 plus 1. Okay, that might seem like a lot to keep track of, and maybe it is. So let's go with -1 to the power of 1 is -1. And then I've got -2 plus 1 is -1. So this first term should be +1. Also, I've just decided I don't like that color. We'll go to blue. All right, a sub 2. So that's -1 squared over 2 times 2 plus 1. So that looks like +1 over 5. So that would be 1/5. How about a sub 3? And just since we're on a roll, I'll change colors again. A sub 3 would be -1 cubed over 2 times 3 plus 1. So that gives us -1 over 7. And I am looking back here, and I realized I just did something wrong. So I'm going to go ahead and erase that, and just know that I very easily could have deleted that, but it's important for you to see that. Sometimes I make mistakes. I try not to, but sometimes I do. So I will go back and correct my mistake. This should have just been 2 times 1 plus 1, which is 3. So this first number is a third. There we go. Okay, back to the third term. I have -1/7. You guys go ahead and get in that fourth term. Pause it here. All right, so hopefully when you guys did that, you got 1 over 9. If you take a look at the way that this sequence kind of works out, you have an even number, a positive, a negative, a positive, a negative, right? Because this green one should be -1/3 right here. And the reason it does that is because, again, we're raising -1, which is our numerator, to a power. And when you raise -1 to a power, you will alternate between positive and negative values. Right now, I'm going to have you do the next problem. Write in the first 4 terms of this sequence. Go ahead and pause it until you get that done, and then we'll take a look at what that sequence looks like. All right, so if you got this done, hopefully what you have plugged in looks similar to this, and hopefully your answer looks like this one. I put 1/2 in place of 2/4 because that's probably what you got. And then, of course, we can't forget our ellipsis or the ... that comes after it. Again, raising -1 to a power will oscillate you between positive and negative numbers. So you always need to keep that in mind. All right, now let's take a look at example 3, where we are talking about recursive sequences. Remember that a recursive sequence is one where you have to know a previous value in order to find the next value. Recursive sequences are defined a little bit different. You will always be given usually a first value, and then the subsequent values will say, okay, to find the next one, you need the previous one, and they usually give you some kind of limit on that. So let's take a look at what this might look like. So this recursive sequence tells us that the first value is 3, so we get to start with 3. And I'm going to just write that down here. Now to find the second value, a sub 2, right? So I'm going to let a equal 2, I'm going to let k equal 2, which you can see k has to either be bigger than or equal to 2. So I have 2 times a to the 2 minus 1 plus 1. Okay, what do I do with that? Well, that just really means 2 times a to the first plus 1. Well, I know what a to the first is. It's 3. They told me that. So that's 2 times 3 plus 1. Okay, so now 2 times 3 is 6. 6 plus 1 is 7. Cool. That's the second term. Let's try and find the third term. So a sub 3 means I need 2 times a sub 3 minus 1, right? Because now I'm looking for that third term. So a sub 3 minus 1, that number plus 1. Okay, so that means I need 2 times a sub 2 plus 1. Well, how do I know what a sub 2 is equal to? Luckily, I just figured out a sub 2. It is whatever this is, which is this. So I need 2 times 7 plus 1. Why do I keep doing that? Let's get that out of here. Okay, so 2 times 7 plus 1, well, that's 15. So now I found a sub 3 is equal to 15. Let's find the fourth term, and this will be the last one that we find on this one. So a sub 4 is equal to 2 times a sub 4 minus 1. Let's erase that better. There we go. So 2 times a sub 4 minus 1, quantity plus 1. All right. So I need 2 times the third term plus 1. And the third term we figured out was 15. So that means that the fourth term in this sequence is 2 times 15 plus 1, which is equal to 31. And this sequence can keep going. We aren't given any restrictions on it. So here's what all of that looks like if you didn't get a chance to write it down. Okay, so first we wrote down the first term because they gave it to us. And that is, let me get a little thing. That's what we get happening right here, right? All right, to my first term. Then to find my second term, I needed to use the first term, multiply it by 2, and add 1. So that's what gave me 7. Now to find the third term, I had to use the second term. And the second term was 2. So 2 times 7 plus 1. And then to find the fourth term, I had to plug 4 in for k, and that told me here, use the third term. Third term was 15. So 2 times 15 is 30, plus 1 is 31. With a recursive sequence, we can't just go, oh, what's the 200th term? We can't do that because we need to know the 199th term first. So just be aware that with these kind of sequences, you have to know prior terms in order to get the new terms. I would like you now to go ahead and try the next one. The way that this one's worded is different than the previous one, but I want you guys to try and figure it out. So go ahead and pause now, and we'll talk about it after you're done. All right, so hopefully you've gotten this done. This one definitely looks different. So here, they told me that a sub 1 is equal to 6. So I know the first term, so I wrote it down right here. Now here it says plug in a number for k starting at 1. So if I plug 1 in here, I get a sub 1 plus 1. I'm going to plug the same number here as I do here, which means this is a sub 1, meaning first term. Add 1. All right, well, I know that 1 plus 1 is equal to 2. And I know that my first term is 6. So 6 plus 1 is 7. That gave me a sub 2, or second term. Do this again. I'm going to plug in 2 for my k, both here and here. And this says to find the third term, I'm going to take my second term, which I happen to know is 7, and add 1. So my third term is 8. I'm going to plug in 3 for my next one, so here and here. 3 plus 1 is 4. This says to find my fourth term, take the third term, which I know is 8, and add 1 to it, so I get 9. Okay, a different way to look at it, but it gives us the same information in a recursive formula. All right, now let's talk specifically about arithmetic sequences. And the way that these are given to us is kind of interesting because it gives us what's called the nth term. So let me highlight that a little bit here. The nth term is this. That's just saying that a sub n equals that. And the important thing here is the question where it says, determine the common difference. So let's start with that. So if a sub n is equal to 4n plus 3, I might write that down. A sub n is equal to 4n plus 3. Cool. So my first term, a sub 1, is 4 times 1 plus 3. And a sub 2 would be 4 times 2 plus 3. And a sub 3 would be 4 times 3 plus 3. And a sub 4 would be 4 times 4 plus 3. So that means that I've got 7. What do we got here? 4 times 2 is 8, and 8 plus 3 is 11. 12 plus 3 is 15. 16 plus 3 is 19. All right, so I've got the first 4 terms. So now I need to figure out the common difference, or the value that we are adding or subtracting each time. Remember, this is a linear pattern. So how do I get from here to here? Well, I'm pretty sure what I do is I add 4. How about here to here? And here to here. So the common difference, which we say is D, is 4. Where do I see that in my formula? Okay, this gets to be pretty important. This 4 shows up right there, or we can say it's here. Right? It's kind of like the slope of the equation when we are looking at arithmetic sequences. I'm going to zoom out really quick so that you can see this page. We have actually finished the notes for this page, and we are just about ready to turn the page. If you need to, here, I'll zoom all the way out. If you need to pause and get anything written down, you can do that now. Okay, so we should now be on page 3 of this. I know that we've been at this for a bit, and I appreciate your perseverance. We are about halfway through. What I'd like you to do right now is to take a look at this next one. The formula is saying that a sub n is equal to 1/4 of the sum n plus 3. So please write out the first 4 terms, and then after you get the first 4 terms, let's determine the common difference. Pause it now. All right, so here's what this should look like. If you plug in 1 for n, you would get 1/4 of 1 plus 3, so that gives us 1. If you plug in 2 for n, you should get 2 plus 3 is 5, and 1/4 times 5 is 5/4. Right now, if you have written down 1.25, cross it out, make a note, Miss Busselmeyer doesn't like fractions, and write this as doesn't like decimals, and write this as an improper fraction. So a sub 2 is 5/4. For a sub 3, you would plug 3 in for n and get 1/4 of 6. That gives you 6/4. If what you wrote down is 6/4, please simplify that fraction. Fractions need to be simplified. So that would be 3/2. And then a sub 4 is 7/4. So these are the first 4 terms of the sequence. So now, what is the common difference? Well, what is the difference between 1 and 5/4? Well, I think that's a fourth. How about 5/4 and 6/4? Well, that's still a fourth. How about 6/4 and 7/4? Well, that's a fourth. And we know that because that's our number here. So now let's take a look at the way that these patterns work. I'm going to zoom out and scroll up. Okay? The nth term of an arithmetic sequence is written in this form. Okay? Oftentimes, it's simplified, so you don't see it written in this form. But take a look at some of the important pieces, like often the first term is going to be written in. And that is your common difference. And I'll even use a different color to say that this is how you are figuring out the next term. So if you look at the pattern they give you, a sub 1 is a sub 1. A sub 2 is a sub 1 plus your common difference times 1, right? You could even write in here, common difference times 1. A sub 3 is your first term, and then 2 of your common difference. That's why we have 2d. And a sub 4 is your first term and 3 of your common difference, right? That's how the pattern works. Knowing this pattern, let's take a look at the next examples. So with this example, they are telling us the common difference, and they're telling us a sub 1. So we can say, okay, we know that a sub 1 is -1, and we know that d is equal to 5. So we know that we can use the formula written above. A sub n is equal to my first term, which is -1, plus whatever the number of my term is, that previous number minus 1, times my common difference. Okay, that is the expanded version. We usually don't write it like this. Normally what we do is we simplify this. So let's go ahead and distribute the 5, right? We do still distribute even though it's on the right-hand side of the expression and not on the right. Doesn't really matter. So a sub n is equal to -1 plus 5n minus 5. So a sub n is equal to -6 plus 5n, right? This is the formula. Your turn. Go ahead and pause it here and write the next formula. So hopefully you've gotten that done, and you knew to plug in 2 as a sub 1 and 3 for d. And then when you distribute the 3 both to the -1 and the positive n, you get 2 plus 3n minus 3. And then when you combine like terms, you have a sub n is equal to 3n minus 1. Now, if you look at the difference here, on the one above, I put -6 plus 5n. And on this one, I put 3n minus 1. And the question might be, does it make a difference? The answer here is no. It does not make a difference. This really is a linear type function. It changes in an additive pattern. So, does it matter what order you write in these values? No, because addition is commutative. So now what we're going to do is we're going to take a look at sequences where we get two terms, but we don't necessarily get them like first and second. We kind of get two random terms. So when we take a look at this problem, we have to figure out how many terms there are to get from the first one that we're given to the second one that we're given, because we have to add that difference that many times. So what we know is that the fourth term and the 13th term are 9 terms apart, okay? So let's start with 13 minus 4 is 9, right? So we can say that they are 9 terms apart. That means that to start at the fourth term and get to the 13th term, we have to apply that common difference 9 times. So the way that you can write this in mathematical notation is to say, okay, if I want to get the 13th term and I start at the fourth term, what I have to do is add my common difference 9 times. So once I have that set up, I can plug in the values that I know exist, meaning that the 13th term is 65, and the fourth term is 20. So I can figure out, that's not what I wanted to do, I can figure out D by just solving this equation. All right, well, 65 minus 20 is 45. And that means that my common difference is 5. Now that I know that, I can either work backwards from the fourth term, or I can solve algebraically to find the first term. And since I'm a math teacher, that's what I'm going to do. I will say that I know that any term has to be equal to my first term plus n minus 1 times 5, because I just figured out 5 is my common difference. Well, let's plug in some things that we know. I know, for example, that a sub 4 is 20. So I'm going to take a couple of extra steps just because I want to make sure that you guys see where I'm getting these numbers from. So a sub 4 is 20, and I can use that to find the first term. So the first term in this instance is 5. So I can write out the first 11 terms if that makes me happy, right? So I start with 5 and I add 5 each time. Oh, that's easy. Right, so now I've got my first 11 terms. I didn't have to plug it in every single time because I know what my common difference is. My common difference is add 5. And if I do that each time, I don't necessarily have to plug it in. All right, so that's the end of page 3, and we are so very, very close to the end of this section. If you need to take a look at any of the problems, go ahead and pause, zoom in, do what you have to do so that you can get these notes in. Turn the page, and I would like you guys to try this one on your own, not on your own individually, but maybe with a partner or in your teams. Okay, so to solve this, I did pretty much what I've done in the previous example. First, I had to figure out how many times I had to apply my difference, right? To get from the 8th term to the 12th term, I have to apply that common difference 4 times. So I know if I want the 12th term of the sequence, I have to start with the 8th term, and I have to add my common difference 4 times. So my 8th term is 41. I'm sorry, my 12th term is 41. I start with my 8th term, and I add my common difference 4 times. Well, now this is just a linear equation that I can solve, and I find out that my common difference is equal to 4. From there, I can figure out my first term. Here's my function. To find any term, I start with the first term, and I add the common difference 1 less than that number. So to find the 8th term, I had to take my first term and add my common difference 8 minus 1 times, which is 7. So 25 is my 8th term, and I have to take my first term and add it 7 times 4, which is 28. So what I find out here is that my first term is -3. Once I know the first term and the common difference, I can write out as many as I need of this sequence. So here are my first 11 terms. I can also check to see if my 1, 2, 3, 4, 5, 6, 7, 8th term is what I said it would be, which is 25. 9, 10, 11. If I add 4 more, would I get 41 as my 12th term? Sure would. So that is how I know that this is correct. So now we're going to look at this a little bit differently. One more time. Find the 9th term if we know the first 2 terms. Okay, you've got 2 options. One is you can write the formula. One is you can figure out the difference and add it that many times. I am going to go with the formula because that is the more algebraically appropriate method to take. So let's get started on that. I know my first 2 terms are 2 and 9. So a sub 1 equals 2 and a sub 2 equals 9. If I have that, I can figure out that my common difference is 7. So I can say that a sub n is equal to a sub 1 plus n minus 1 times 7. A minus 1 is 2. I'm sorry, a sub 1 is 2. So a sub n is equal to 2 plus n minus 1 times 7. So if I want to know the 9th term, cool. A sub 9 is equal to 2 plus 9 minus 1 times 7. So let's just do that computation. That is 2 plus 8 times 7. So hopefully we know that 8 times 7 is 56, plus 2 is 58. So the 9th term is going to be 58. You pause here and go ahead and do this last problem. Okay, so I know that my first term is 7 and my second term is 15. From there I can figure out that my common difference is 8, right? I did a couple of less steps, no I didn't say that right, than the previous problem, but I don't have to show every single one of those steps. I know I'm looking for the 10th term. I know I have the first term. I know I need to add 10 minus 1 to my difference, and I know my difference is 8. So I can plug all of that straight in. 10 minus 1 is 9. 9 times 8 is 72. 72 plus 7 is 79. I'm going to zoom out so you can see the entire page on this one and get anything written down that you haven't been able to. From this point, you should be given your homework assignment. It is also posted up on Canvas. Like I said earlier, I will be in class on Thursday, and we will move onward from there. Thank you so much for your understanding, and I can't wait to see you guys on Thursday.